Welcome, ladies and gentlemen, to the Technical Forum of Hydrogen and Fuel Cells Europe. To keep hydrogen in a bottle is a big issue. How can we keep it? And for this question, we have a specialist here. It's the segment account manager for leak detection of INFICON. It's Steffen Mähler. Steffen Mähler, would you come to the stage? Here you are.
Thank you. Hello. All okay with the microphone? Yeah. Okay, hello, I'm Steffen Mähler, and welcome to this presentation about the important role of leak testing when working with hydrogen, when handling hydrogen. It seems these days everybody is talking about hydrogen. Hydrogen, not only here in this trade show area, also worldwide, globally, within Europe, and especially in Germany. Hydrogen seems to be the big thing to overcome all of our environmental issues, to change our, to reduce our CO2 footprint, to become green, and also to bring our change in energy supply much quicker forward. And even now, with the terrible war in Ukraine, many especially European countries are forced or have a need to get rid of their fossil fuel supplies from Russia, and hydrogen seems to be a solution. But remember back on school days, some lessons in chemistry. There is something tricky with hydrogen, and what you see here is probably the first huge disaster in human history related to hydrogen, when the hydrogen charge of this Zeppelin Hindenburg ignites during landing procedure. And now, of course, you may say, yeah, of course, it's inflammable. We like to replace fuels with hydrogen, so it should be inflammable. Yeah, but there's something different. Let's look into some details. What you see here are the inflammable limits of different well-known fuels and substances compared to hydrogen. And what you see here is, it depends a little bit from which source you use, but what you see is that the range where hydrogen can form explosive and inflammable mixtures in air is much larger compared to all the other substances. Especially when you compare with natural gas, hydrogen starts to form a flammable mixture at 4%, something around 4%. Natural gas is 7%. So leaks are an uncontrolled source of emitting hydrogen, of creating potential explosive atmospheres. So a good leak test procedure is essential for your workers' safety, for customers, consumers, but also for the quality of your products. They should work efficient and they should work reliable. So if we take a look on the, let's call it, life cycle of hydrogen, from its generation to storage, distribution, and at the end also the consumption of hydrogen. In all these applications, you may have completely different needs in terms of leak testing. In some applications, you may have a need for a very, very small, cheap leak detector, which you can easily put in your toolbox and then just go out and do a quick and dirty service leak test. In other applications, you may have a need for a leak detector which is robust, water protected, and allows you a good, comfortable leak test of ground floor gas pipes and gas grid. And then you may have a need to measure leak rates or to measure gas concentrations as well, to pinpoint leaks with a very sensitive technology. And if you work with pure hydrogen, you may also have a need for an X-proof detector, which you can use in explosive potential explosive areas in ATEX environments. And at the end, in some production areas to leak test your products, you will probably need leak detectors which you can implement in completely automatic test systems. And the good news is, for all of your needs, you will find the right leak detector within the INFICON portfolio. And not about just leak testing, also in the field of gas analysis and gas quality measurement. Now let's jump into a specific application. Leak testing of fuel cell vehicles. In such a fuel cell vehicle, we have many parts which needs to be leak tested. It's the tank, of course, the hydrogen tank. It's the fuel cell and a lot of electronic components, motor, control unit, and the battery, which needs to be protected against the ingress of water. Now let's jump into the fuel cell testing. And the fuel cell consists of several bipolar plates, which are split by or separated from each other by a membrane, combined to a complete stack. What you see here is one bipolar plate with the channels for the hydrogen, for air, or for oxygen. And if you combine it together, then you will end up with a complete fuel cell stack. And to create such a bipolar plate, you simply take two formed metal sheets and weld these metal sheets together. The yellow dots are the welding positions, so that you in the end create a cooling circuit, an air circuit, and the hydrogen circuit. And these welding spots are now the potential leaking areas where leaks can occur. And in this overview, you can see 9 different scenarios how leaks can occur. You can have leaks to the outside, you can have leaks from one channel to the other channel, and each of these scenarios will have different impact on your product and on the environment. Of course, some of these scenarios are similar. So a leak from hydrogen to air channel is the same like air channel to hydrogen channel, so that you finally will end up with these 6 scenarios of possible leaks, which you need to find a solution to test for. Now, if you ask what's the leak specification and the leak size which is allowed, then we can have a look into this DIN standard, which gives some indication, which gives a leak rate of 5 cubic centimeters per minute for a whole stack, fuel cell stack. And this is applicable for pure hydrogen. We can now convert this leak rate into a helium leak rate. Helium is a typical tracer gas for doing leak tests. And we end up with this leak rate. And if we now assume that the typical fuel cell consists of 300 to 400 bipolar plates, you can simply end up with the leak specification for each bipolar plate. So they are typically tested in the range of 10 up to the -4 to 5 millibar liter per second. So now you need to find solutions how to test your bipolar plates, and just one solution is to put it in a vacuum chamber and apply helium as a tracer gas onto your hydrogen channel, and then in the vacuum chamber you can measure if you see any helium, which is an indication for an outer leak or a leak to the outside or a leak into the air channel. And this of course applies to all the other scenarios as well. If you tested each bipolar plate, then of course there can also leaks occur if you combine the bipolar plates to a complete stack because of faulty faulty sealings or faulty membranes, that can still in the assembly leaks can occur. And so you can also test, or you have to test, the complete assembled stack again, which you can also do in such a chamber. You pressurize the cycle you like to test and measure if you can see any tracer gas inside the test chamber. In case you have a leaking product, then of course it's important for you to know the location of the leak, not to disassemble the complete stack. And in this case, you can over to a so-called sniffer leak test, where you can locate the leak position with a sniffer leak detector with a hand probe. You scan your product, and that's it. Okay, and this is just, due to the limited time, a rough appetizer for you. So if you're interested, learning more about leak testing, learning more about the application, if you have more questions, please visit us on our booth. It's right here in this hall. D61 is right this direction. So I'm happy to welcome you on our booth. Thank you.
Thanks a lot, Steffen Mähler. Great presentation.
Questions?
Other questions? Right, we have 2 minutes left.
Have 2 minutes
one
left.
minute, one or two questions. I guess this is a very essential contribution to the progression of hydrogen and the applications. Without keeping it, we are losing it. So thanks a lot.
Yeah.
And we'll see you again and visit him at his booth, D61.
Thank you.